Well, thank you everyone for coming. This is a topic that is always in the news, as we all know. Vulnerabilities and components, whether we use them or not, is the subject of many breaches. So in this talk, we're going to be talking about the ability to continuously analyze our components for various types of things, regardless of whether or not that software is being built or not. So Dependency Track is a open source continuous component analysis platform. Gartner and Forrester may call that software composition analysis. I think that's a terrible term. It doesn't take in environmental things, runtime, and it's specific to software. And as we all know, hardware also has vulnerabilities, and Dependency Track can monitor those components as well. Dependency Track works on the concept of software bill of materials, where basically we tell Dependency Track factually what components we have. From then, it monitors all of the components that it's tracking for known vulnerabilities as well as out-of-date components. Out-of-date components is really, really important because only a small portion of all publicly disclosed vulnerabilities, of all vulnerabilities, excuse me, are actually published to things like the NVD. It's always a good practice to stay up to date. It does track open source license. This is not a strategic part of the project. The evidence is there, we will use it, but being an OWASP project, I'm focused more on the security aspects, not necessarily the license and compliance aspects, although I do accept pull requests. It has an auditing workflow, much like static analysis tools, Fortify, checkmarks, etc. You have a bunch of findings, and those findings may or may not be relevant to your particular product that you're working on. So you can mark things as false positives. Maybe you can mark them as not applicable to your application. You can produce a comment trail. You have a complete audit history, as well as marking things as being suppressed so that your metrics and whatnot are nicely affected by that. And finally, it's built really for DevOps, and it's designed with an API-first design, but I think some of the features in here, you'll see that we don't just embrace DevOps from the automation standpoint. We do kind of embrace the cultural aspect in Dependency Track as well, and I think we do a pretty good job of that. So what is a software bill of material? It's a list, right? It's just a list of things that we have. It is a list of ingredients that our software, our in an IoT device, our pacemaker, whatever it is that we are working on, it is a list of all the ingredients that goes into that thing. So conceptually, Dependency Track is this. You have an asset, piece of software, microservice, pacemaker. You create a bill of material for that describes all the ingredients, and you throw it into Dependency Track where it will constantly monitor it, whether you're building that software or not. Now, the generation of the bill of material is really simple to do. It can be automated, and this is ideal to be put into a CI/CD pipeline. So you're constantly generating the bill of materials, and you're putting it to Dependency Track on a continuous basis, and you basically end up with a loop within a loop, right? So you're continuously analyzing things, whether or not you are building them or not. So, and this is really important. When organizations create software, they typically create multiple versions or support multiple versions of the same thing. And you might be at version 3.0, but you still have some 1.0 in the field, and you still support it, but you don't build it every day. But you still want to check your components, right? Well, you might have a bunch of microservices. Say, for example, you've got hundreds or thousands of microservices. These development teams, they go from one service to the next to the next. Outside of a few core services that are really important to your business, you're not working on all 1,000 services all the time, right? But you still need to monitor those without necessarily having to build everything all the time. So the types of analysis that we do, vulnerabilities, outdated components. So for vulnerabilities, we check the NVD. We integrate natively with NPM public repositories using NPM Audit API. Big thanks to Sonatype for supporting OSS Index and rolling that out. And we've got partial support for VulnDB. We're kind of working on that a little bit as we go forward. For outdated components, we currently support Ruby gems. There's like 9 or 10 public Maven repositories that we support. NPM and NuGet is in development. So bill of materials support, we support 2 different types of bill of materials, CycloneDX and SPDX. CycloneDX was written specifically for dependency track. It is a very lightweight specification. It is designed to be essentially the minimal viable product of what a bill of material should be with an application security focus. So it is the recommended way to do this. SPDX is also supported. SPDX is a much older bill of material specification. It's used by Black Duck and a few others. But it has historically focused mostly on license, copyright, compliance, that type of thing. There is a new version of SPDX coming up, version 2.2, which at that point, I'll also be able to say that that's also recommended. Although not a bill of material, we also can ingest dependency check reports as well. So generating a BOM is really simple. You basically start with something that's native to your ecosystem, Maven, NPM, there's a .NET Core module, there's other things in development. The specification is really super simple to understand. You could probably create something for Ruby or Python in a few hours, actually have something of production quality within a day, maybe 2 if you're slow. But it's really, really simple to get started. This is what a bill of material actually looks like. For the sake of screen real estate, I only have 1 bill of material listed here. But as you can see, this is a type of library. It's REST easy from the JBoss project. It's got a bunch of file hashes. It has the SPDX license ID. And then it has this thing called Perl or package URL. This thing is very, very important. It is a standardized based way to represent your components irregardless of what ecosystem that component is a part of. So instead of having Maven govs or the Ruby version of that or the NPM, you've got one representation regardless of ecosystem. I can describe Maven or NPM or Red Hat package managers, pretty much everything. But it's really important. I know CycloneDX supports it, Dependency Track supports it, Sonatype OSS Index supports it, Red Hat is in the process of supporting it, a few other folks. But basically, it is a decentralized URI. It actually conforms to the URI specification. There are a bunch of parsers out there. I wrote the official Java version of that, and I'm also part of the group that's helping define the specification. But there's implementations for JavaScript, for Ruby. I think there's a Python. There's a .NET one out there. So definitely go check it out. So dependency track, once you actually ingest your bill of material that's top left, we work with the multiple sources of vulnerability intelligence, and we also do the outdated version detection. So once you actually have the bill of material in dependency track, we're going to constantly analyze that. Now, every time you upload a bill of material, we're going to analyze it. But if you don't upload a bill of material, we're still going to analyze it every 24 hours. But it doesn't do anybody any good if the information just sits there, right? So we've got notification support, so you can actually get Slack or Microsoft Teams notification. The really interesting thing, though, is to be able to automate your response. So we have webhooks, and the data that we actually provide in webhooks allow you to do some really interesting things. So for example, if you have a library and you discover that it's vulnerable, well, you can automate that response, so you can send the webhook out, and maybe it's a library and maybe it's a minor version, so you might, in that particular case, you want to automatically do a pull request to update to the latest version. Or maybe it's a framework, or it's a major version update. So in that case, you might want the business response is going to be to automatically create a JIRA ticket to go into the team's backlog to fix. So it's really up to you how you kind of use that functionality, but we provide a ton of data that you can really use via the webhooks. We do have our own Jenkins plugin now, and for ThreadFix customers, you actually get a ThreadFix remote importer from Denim Group, supported by Denim Group. We're working on other vulnerability aggregation things as well. Kenna security support is coming up, and I will be writing a Fortify SSC plugin as well, so you'll be able to get your static analysis results and your component analysis results in a single pane of glass. Questions before the demo? And please pray to the demo guys for me.
Are you able to bring any component with PUI? Because that's the problem. I'm not using JBoss. I'm finding out which version of the JBoss is viable before I even use it in my program.
Right.
Or find the correct PUI or whatever.
Right. So the question is, how can you use package URL or Perl to query for vulnerabilities just using that string, right? So dependency track actually, and CycloneDX really puts a big focus on package URL just because it's a standardized representation of any component. We treat package URL as kind of a router, right? So if I have a component that I know is of the NPM variety, I'm going to automatically use NPM audit API. You don't have to know that. The system just does that for you. Whereas if I have something that has like Maven, I might choose to do OSS index. If I don't have a package URL, I'm going to use dependency check internally and do my fuzzy matching voodoo stuff against the NVD to try to pull some of that stuff back. So package URL is really important. OSS index, the service provided by Sonatype, actually uses package URL natively. You have to use it in order to use the service, and that's how we integrate with them. It's really simple, actually. It doesn't have to be, unlike a URL, it doesn't have to be resolvable. So essentially what you do is, in the case of Maven, for example, it's going to be PKG : Maven, and then / the group / the component name @ the version. That's it. The group is optional in a lot of ecosystems. For example, in NPM, the organization or the group is an optional thing. In things like NuGet, it doesn't exist, right? So you just omit that. Yeah, it's really simple. Yeah.
So some cities never show up in the meeting for different reasons.
Yep.
So can you cover those cities?
So that's a great question. So the recommendation, regardless of whether or not you have vulnerabilities in your components, is always going to be keep your components up to date. It's a best practice from just a hygiene perspective because you get performance and bug fixes and all that. But when you have something like struts or Spring that gets popped, especially struts all the time, you need to be able to respond within hours sometimes or less because those things are typically weaponized within a few hours, right? So it's really important for you to keep those things up to date on a very consistent basis, because if I'm a few versions behind, I now may have to deal with API changes to do that upgrade. Whereas if I'm continuously upgrading, I can just, update the thing and I can probably not even test, right? I can just go forth and deploy. But the question was really about the known vulnerabilities that are not in a thing like the NVD, which is about 90% of all vulnerabilities. That's a really hard problem to solve. There's a lot of really good commercial sources of vulnerability intelligence Sonatype, Nexus IQ, for example, has some really good stuff. Snike, who I'm actually in the process of trying to integrate with, they actually have some really good stuff as well. For example, package URL with Snike, they actually have REST APIs for each ecosystem. So like the REST API for NuGet is different than the REST API for Maven. It's crazy. But if they were to standardize on package URL, you wouldn't have to worry about you know, what ecosystem that package is actually, and you have one API that you can then query. I'm trying to get them to support that, but I think the package URL really has a really big potential impact for things like commercial sources of vulnerability intelligence. So VulnDB, for example, is a commercial source of vulnerability intelligence that we integrate with. They had, what was it, 6,000 vulnerabilities in their database that weren't in the NVD in 2017. We support that. So, yeah, and it's only going to get better.
Another question about SPDX. Do you build your own like SPDX for different kind of packages, or do you see like outside support? The reason behind that, right? There are some discussion about do people want to support SPDX or other formats,
Right,
like software identification ID3, right?
right.
So there are a lot of discussion about which one you should support in the future, not right now, right?
Right. Are you on those working groups? There-
Somebody back group in the working group. but
Yeah.
We are discussing how we can,
Right. Yeah, so there's actually a couple working groups going on right now at the, in the federal government. I'm actually part of two of those working groups that are discussing software transparency at the government level. Yeah. And, yeah, it's a really hard problem to solve because there's a lot of use cases. Cyclone DX doesn't handle every single use case. It's not designed to. It's really designed for that minimal viable product for you to be able to generate the bill of material from your build system in a very easy, automated way to get results. SPDX, you know, it's an older standard. It's supported by things like Black Duck. It's supported in Dependency Track. It was designed not for software security. So there's the package URL and some of these other fields aren't in the specification. Yeah, it's, but version 2.2, they're actually adding some of these things. So we'll see where it goes. Software ID or SWID, I don't support because the specification is behind the paywall. So if they ever change that, I'll support the specification.
What is the follow-up on the first question? Can we build our own custom database and
Vulnerability database?
Yeah.
You can.
like in subgroups?
Yes. Yeah, so if you want to, as an organization, if you want to create your own internal private vulnerability database, you can do that today. Yes.
Follow-up question. And the second question is towards the JavaScript.
Mm-hmm.
You mentioned that support. So how does that match to the URL, like finding a JavaScript, third-party JavaScript?
Third-party JavaScript to the URL, like the package URL? Yeah, so it'll just be package, PKG, where's that? Let's see. So it would literally be package, NPM, the optional organization. So the optional organization would be there. If you had one, / whatever the name of the component is, @version. That's really it. And there's actually a Cyclone DX NPM module that'll automatically create your bill of material from package JSON. So if you have a node project, you can actually create all of that with one command.
For the existing open source JavaScript, is it pre-built?
What's that?
For the existing JavaScript open source libraries, is it pre-built like this one, or is it like define every JavaScript?
Well, if you're building with NPM, if you're using a JavaScript package manager, right, it'll do everything for you. If you're using unmanaged dependencies, that's an entirely different problem.
Yeah, like trying to figure out what JavaScript is.
Right. Yeah, that's a different problem.
Actually, we can use dependency check to generate build
Well, dependency check, it's not a bill of material. It does provide a report that does have some of that information in there. It's not a true bill of material. It's limited and it's inconsistent. So, for example, if I were to scan a package JSON with dependency check, the dependencies and the transitive dependencies are actually represented differently than some of my other components. So I don't necessarily get all the information that I really need, nor does it support package URL, which is really important. There is a backlog item for the dependency track or dependency check to support package URL, and if they ever do support it, you know, I'll be able to support that a much.
So your recommendation is cycling, yeah.
For accurate results, yeah. If you want, there's really two interesting use cases for this. So like if you want very specific actionable results without a lot of noise, if you want a very clear signal to noise ratio, use CycloneDX and use, you know, the Maven, NPM, whatever to generate it, and use NPM audit and OSS index and disable dependency check. Now, if you want to cast a wider net and be able to get environmental things, or maybe you are working on a legacy project that doesn't have Maven or whatnot, then in that case, turn on dependency check and it'll find those types of things, but at the expense of false positives.
Sorry, quick question. How does the tool handle the notification and the tracking of issues if let's say I submitted my BOM a month ago and there is a vulnerability today, does it notify me? Does it allow me,
Yeah.
you know, to customize who else would be notified and so on?
Yeah, so the notification support, it actually keeps track of all the history of the components and the vulnerabilities. It also keeps track of all of the analysis decisions that you've made. So for example, if you have a bill of material that you ingested like a month ago, and there was no vulnerabilities, and a month later there is, if you have a notification configured, and it's like a 2-minute process to configure them, but if you have a notification configured, you can get a Slack notification, Microsoft Teams, webhooks. We also support email notifications if you want email. It's really up to you.
Does it allow acknowledgement that I received the notification and yes, I addressed it?
No, no, no. Eventually, there will be like Jira integration with bidirectional thing. I accept pull requests. Yeah.
So last question. So how can we find out what's inside the bill of material? What I mean here is that, for example, you mentioned Struts 2, right?
Mhm.
They pay attention to Struts 2. But a lot of people don't know, like JSON databand actually inside Struts 2. So whenever JSON databand has some vulnerability coming up, how can we, you know, notify Struts 2 and, you know, get it fixed?
So what's the question specifically?
It's like what's the second level dependency? What's the inside the bill material?
Right.
So do you have any tools to do that, or do you have any suggestions?
Right. So when you generate the bill of material, it is basically a flat representation, because that's what a bill of material is. So its bill of material is not a dependency tree, first and foremost. It is just a flat representation
It's
of.
like first level, what
Yeah.
included, right?
But it does include all of your transitive dependencies. So when you do create the like Maven or NPM, when you do create your CycloneDX bill of material, you will get all of your transitive dependencies.
But do they know, like, JSON databand actually is under Struts 2?
It's under Struts too.
Probably
Yeah,
you-
transitive, yeah. Yes, they will.
You do have the relationship between these two?
Yes.
Okay.
Yes, yeah, it's in there. All right, let's, how much, we've got 5 minutes?
Yeah, 7.
7 minutes? Okay. Okay, so here is the main dashboard for Dependency Track. I am going to go ahead and create a project. Let's do WebGoat. And this is version 8.0 of WebGoat, I think. Okay, so I've got an empty project in Dependency Track. I've got a Jenkins installation over here, and I've got a job. Let me just show you the configuration of the job here. So this is OS WebGoat. Looks like I'm pulling it from, I might not want to do that because I don't want to rely on the internet right now. I would normally end up building, right, building WebGoat, but in this particular case, I just want to generate the bill of material with all of my transitive dependencies. So this is what this does. So it just calls out to the Maven plugin directly. Ideally, this would be in your Maven profile or part of your build step. The next thing I want to do is I want to publish my results then to Dependency Track. It's automatically going to populate my full list of projects. I only have one to find there. And I know that the bill of material will be in my Maven target directory, and it will be called bomb.xml. So let's save that and run it and pray to the demo guys that it works. Okay, so right now it's making an aggregate of all the components that are in there. See how long this takes. I'll come back to that. One thing that you can do with Dependency Check or Track is it actually maintains a full list of all the vulnerabilities. So if you want to do analysis on things in the NVD, right? So for example, CVE 2018 something or other, right? So this one's is high severity. You get all the metadata about what it is, right? You get the base impact exploitability scores, links out to NIST for that. But you also get, if I had any projects in my portfolio, in my enterprise, right? You'd actually get a list of all your affected projects. So if you were to use this to monitor, like for example, all of your commercial software, right? A lot of organizations have hundreds, if not thousands of applications that they use that they didn't develop. Well, now you can, instead of when that next Heartbleed comes out, right, you don't have to call every vendor because that's not scalable. You can now look at Dependency Track and see which applications across your enterprise are actually affected. Okay, so this is done. It looks like it created my bill of material and it published the artifact to Dependency Track. So let's go back to that project that I created. There you go. So I've got a bunch of vulnerabilities now. If I go in here, so these are all my dependencies. Some of these things it may not be able to resolve. These things will tell you whether or not it's out of date or not. The little green ones tell you that it's actually the latest version. And then you can go over to audit. And these are all of the findings that it found. So I can go over to, looks like I'm using a vulnerable version of Tomcat. So you can go into each vulnerability here and make your analysis decisions. Again, just like a static analysis tool. You can mark things as being exploitable, suspicious if it's under investigation, not affected, right? Yeah. Correct. So it really depends on the source of vulnerability intelligence, like OSS Index, provides a lot of that. The NVD obviously does. Node Security Platform used to, NPM no longer does. So with NPM, for example, you don't get some of the CVSS scores, nor do you get the vectors. So those pretty little graphs and stuff, you no longer get with NPM. Yeah.
There is a CWE, do you have any CWE?
What's that?
If the vulnerability is defined as a CWE and not as a there is no explicit CVE, do you have any mapping for supporting those?
Well, you're always going to, if it's a publicly disclosed vulnerability, you're always going to have a CVE or some kind of unique identifier. Sonatype, for example, has, they actually use UUIDs. NPM is just, 1 through whatever. The NVD uses CVE dash something or other. So depending on your source of vulnerability and intelligence, you're always going to have a unique identifier. Yeah.
So how do you track the versions? The version is vulnerable version, how do you do that?
The vulnerable versions, we don't track. That's almost impossible to track without human intervention.
Yeah, that's how.
Because CPEs are completely unreliable, and the NIST is trying to get rid of them, right?
Yeah, we have the same conclusion.
Right, exactly. CPEs have long outlived their usefulness. They were good for a time, but it really depends on your source of vulnerability intelligence. Like if you use NPM, right? If you've got a node project, it'll actually tell you in the vulnerability information what things you should actually update to. If you're using Sonatype OSS Index, they don't provide that information to non-paying customers, right?
So I believe this question was like in NVD there is also CWE to CVE mapping, right? So,
Right. Yeah, so you can actually go to, like, if you go to the CVE, right, it'll actually tell you what CWE it has. Yeah, so we have that.
But
Yeah.
there are cases where CWE is there but not CVE.
Well, they're always going to be a unique identifier, regardless of the source of vulnerability intelligence. Always.
So if you generate a bomb for every build, right?
Mhm.
And you upload it to the dependency tracker,
Right.
then that new bomb will override the previous version.
Yeah, it works similar to static analysis. So the question was, what happens when you constantly upload bombs to the dependency track, right? It works very much like static analysis, where you're analyzing a bunch of code and you upload, your code for analysis. When you do that, it's basically it's basically the equivalent of stating these are everything that I have as components. It is not an additive process. When you update your bill of material, right, if you're no longer using something, it'll drop off. If you are using something new, it will be added. And for the things that remain the same, it will maintain that history across, forever, as well as your full audit trail. It's language agnostic. Yeah, so we don't care what language that you're using. It doesn't really matter. What matters more in that regard is really the source of vulnerability intelligence. What can they do? One last question before we gotta go.
How do you show if you have multiple sources of vulnerability intelligence, does it just list them separately, or is there any correlation?
Correct. That's a great question. right now, it lists them separately. In the future, it will try to correlate them. Thank you, everyone. Appreciate it.